kind of give some context to what our lab does, and I guess the kind of the library of tree rings that we're building. I'm going to use a specific example of a very old Hemlock chronology that we've recently put together from Dendroarchaeological materials. So I don't know how many of you are familiar with the science of tree rings. I mean, basically you're collecting some kind of samples. Usually it's cores, could be cross sections. You're going to be measuring those rings, preparing them, obviously, measuring them down to the micrometer. You need to cross date all of those measurements of each individual tree ring that you've taken. So it's, it takes a lot of time to go through that process. You're standardizing your curves. You're trying to take out those individual influences on the growth of trees in the forest. You're producing a master chronology, and then you're conducting some kind of analysis. So that's generally how it works. Just a little bit about the lab before I get into it here. So Dendrochronology in Atlantic Canada really started with, in earnest with the Mount Allison Dendrochronology Lab, the MAD Lab, which hopefully you've all heard of before. The MAD Lab actually moved to the U of Saskatchewan in 2013. And so I've started the Acadian Forest Dendrochronology Lab in its wake. So smaller lab, doing probably less work, but still building on that kind of library of tree rings that the MAD Lab established over a 10-year period. So Dr. Andre Robichaud is with UDM in the Shipton campus, so he's still doing a bit of work with me. And Colin LaRock, the director of the MAD Lab out at U of S now, still collaborates as well. And I'm not sure, I know they had some equipment at mine and they were doing a bit of work there. I don't know if they still do any tree ring analysis over there. But the Acadian Forest Dendrochronology Lab, obviously not really focusing too much on Newfoundland. So the objective of the lab is to measure that environmental signal captured in tree rings across space and time, but also across species. Conditions obviously vary across space and time, but they're recorded by different species in different ways. So different species will be sensitive to different things in the environment, so it's very important to look across different species. I just want to throw up some examples of some live, or chronologies produced from live trees in New Brunswick actually. So there's 6 sites here, basically making a circle around New Brunswick. So we've got some northern sites, some kind of mid sites, and some more southern sites in there. And these are all Hemlock chronologies. Some of them are quite young, they only go back just over 100 years, some of them are much longer. Cut them off at 1850 there. It might be a little hard to see the years down the bottom x-axis. But you can see that throughout New Brunswick there are synchronicities going on between these different chronologies. So they're related to each other, they're the same species, they're in different areas, but they're kind of picking up a similar signal. If you look, these are chronologies from Fredericton at Odell Park. So you can see 6 different species that were sampled in Odell Park. So this is a good example of these multiple species picking up a different signal in that environment. So we don't see a lot of interrelatedness, even though they're from the same forest. There's not really a shared signal as much across the species. So you get an idea of why you need to look at different species in order to reconstruct different environmental signals. This is a very bad map, but it gives some idea of where we have chronologies. And it's missing actually a lot of data. So those ones I showed you a second ago, there's some up near Charlotte, some up near Evanston. Actually do quite a bit of work in the Mississippi protected area up here. There's even more in Fredericton now. But you get an idea of the distribution of where we've created chronologies, where we've done sampling. Obviously, there's a big hole here in Nova Scotia, so we've done very little work in this area. Lots down in southwest Nova, lots in southeastern New Brunswick, not much in southwestern New Brunswick, and not much kind of in the central area of the province. So there's definitely holes that need to be plug there, and more samples are needed. And here's just a few examples of some of the forests we've sampled in some of the trees. So this is a photo of the really old stand in Fundy National Park where the 465-ish year old red spruce was found, and that's actually this guy right down here. They can see it's in a stand, very tall, slender trees with very small crowns. So not huge old trees, just very old, small trees that have been growing in a low light environment in the fog forest. Yesterday, when we were out in the Victoria Park in Truro, we talked about some pines. So I mentioned I would throw a few slides in here of some big pines, because often the way that I'm looking for trees are these characteristics of exfoliation and the tree dropping lower branches, and this is a great example. I mean, this white pine here from the Nipisiguit protected area, you could literally climb the tree on those big furrows in the bark. Like your foot would fit in between some of those furrows. And you can see how all of the lower branches have been completely dropped. There's no record of them even protruding through the bark. They were dropped so long ago. So those types of characteristics tell me that this particular stand of trees is really old, and I'm going to invest my energy in coring them. If I don't see those, then I'm not going to waste my energy coring young trees that I'm not really interested in. Red pine from the Nipisiguit protected area. I mentioned these yesterday. This is a 300-year-old red pine, and there was a bunch of them in the stand. Red pine usually only grows to maybe 150 or 180, and often we don't find them even that old. So these are pretty exceptional trees here. And again, you can see the bark on these trees is really exceptional. Those strips are almost as wide as your body. So very stand out in the forest, quite easy to spot. So those are the types of characteristics that I'm looking for in old growth. But old growth is very limited. We don't have much of it left. And it's difficult to find, a lot of work. So this is where dendroarchaeology comes in. So this is the old growth forest. We talked about kind of the semantics of what the terminology of old growth forest. I mean, to me, it's literally old growth. I'm looking for trees that are very long lived, so that they have the environmental signal captured. In buildings that were constructed anywhere from mid-1800s and before, you end up seeing beams that were axe hewn, so you can actually see these axe marks on the sides of the beams. And if you find something like that, you know that they were basically just cut down in the backyard and constructed into that building. They weren't moved and shipped out. This building was built by hand on site from the forest that was there. So this is a great record of old growth forest, kind of pre-settlement trees. Sometimes there's second growth involved in these buildings, but the Treering Record is there, so it's a great resource to have. Sometimes it's not buildings. In this case, we're sampling wharf pilings. And there's the Treering Record is also captured in there. And there's, we've dated old hockey sticks and potential Stradivarius violins and even a railing from the Titanic. But those types of things don't have any sample size. They're one tree. That's not telling me too much. I need lots of replicate samples. So we need to go to a forest or a building that has lots of trees in there, so we can take lots of samples. So dendroarchaeological priorities. Well, structures with rare species are really cool, because most buildings are made of spruce and red spruce often in this area. Really old structures, because if the building's constructed, say, in the 1700s, then that Treering chronology contained in the structure is going to go much further back in time. Structures containing beams with very tight rings, so longer chronology, more important. Structures that are at risk of being torn down. Once it's torn down and that wood's gone, then the chronology is lost as well. All the information in the street is gone. And structures undergoing renovations are awesome because I can get into the walls. Usually if you go into, well, this is a it's a recent building, but this structure, this is often what you get. Drywall on the walls, you can't get it to the posts in the walls, but you can maybe get into the attic and sample the beams, or down in the basement and sample the floor joists down there. So specifically, I talked about this Hemlock chronology, and this is a good case study here. So we salvaged this Hemlock from Pink Rock Wharf. The wharf was built in 1906 for gypsum, gypsum extraction, and it was abandoned in 1921. Locals said that the wharf was disassembled in the 1990s. So that gives it about 85 years sitting in the intertidal zone. And it got eroded by tidal currents, sediment in the tidal currents, thousands of freeze-thaw cycles over the 85-year period, and lots of ice cake erosion. So that's removing often the outer rings. And then it sat on land for 20 years after that, just decaying. So that's a harsh environment for wood, but we could still sample it. So Pink Rock Lake, for those of you who, I'm sure probably nobody in this room knows exactly where that is, so it's on Maritime Peninsula. It's just a small little sinkhole lake. So this is zoomed in, so you can see kind of the footprint of where the wharf used to be, and then you can see up here, there's a zoomed in version of the pile of logs from where they disassembled it. So we went, or actually I took a piece of wood, because what type of species is this? Is it even worth sampling this pile of old, crappy, decayed logs? Is it worth any effort? So we took a sample, put it in a scanning electron microscope, and it actually turned out to be hemlock. So this is what we often do, because you don't have bark, you don't have branches, you don't have identifying characteristics for the tree species, so you have to rely on the cellular wood anatomy. In this case, we've got no resin ducts, we've got paired bordered pits in the axial tracheids, we've got transverse tracheids up here with bordered pits, and we've got cupressoid and piezoid pits in the ray cells. So dead ringer for hemlock. So that meant, well, hemlock's a really important species that we're looking for. So yes, this was actually worth going after. And a little background on hemlock, for those of you who maybe don't know the history too well. Hemlock was heavily logged between 1870 and 1900. The bark was mostly used for tannins in leather production, and as you can imagine, Tantramar Marsh area is very close to Cap Maringouin, the Pink Rock Lake area, and there was a lot of cattle coming off of those marshes, so they needed a lot of tannins to tan wood for export, so that means you need a lot of hemlock bark. Hemlock's also used, the wood was used for wharves and railway ties, but often it was just left in the forest to rot there once they removed the bark from those big old trees. And there was studies actually done at the time that quantified the amount of bark per acre. So that really shows you how much of a commodity it was. And then, if you look, Donna's still in the room?
Yeah, I'm here.
You look back at some of Donna's work from Kuchipakwack, you see how important hemlock was as a species on the eastern lowlands of New Brunswick, and how kind of ubiquitous those big old hemlocks were at one time, and now they're virtually gone. So that means very important species to sample, because there's not very much of it left in the landscape in New Brunswick. Lots of it in Scotia, but not New Brunswick. So this is the pile of logs. We went in January. The logs were frozen, so all that decayed wood was frozen together, which may or may not have made it easier for us. The logs were full of sediment and rocks and everything from the intertidal zone for a long time. Went through a lot of chainsaw chains. very annoying to cut, but we got through them. This is what the wood basically looked like once we sectioned it. Took it back to the lab. We had to dry it. A lot of these are too big to even fit in the drying oven, so we just put them for weeks under a fan to dry them out. And then we glued paths. We don't want a whole bunch of these huge old cookies. It takes up way too much space in the lab, so we just wanted to remove the part we don't want. And so here we are gluing paths across the cookies so that we can cut out the rest. And we're gluing plywood on here so that it doesn't fall apart and we don't lose the most important part of the cookie. So here's a couple examples of what they look like. It took a lot of gluing because it all seeped into all those cracks. There was lots of open spaces inside. It was weeks and weeks and weeks of just reapplying the glue. Finally, we got them glued up, took them under the bandsaw, cut away everything that wasn't glued onto plywood, and then we were left with plywood strips. So here's one right here. If you guys want to pass that around. So here, sanding those strips down, obviously way easier to sand and prepare that surface. We ended up with a couple shelves full of these strips, and then sent them under the microscope. Actually, put this slide in here to show that some of them were so badly degraded. This is the best part of the cookie, the cross section that we had left. So we actually had to fill them with paraffin wax before the sanding process to keep holding them together, and then try to, measure a transect through that degraded stuff. So here's kind of finished sample. I think this might be the one that I'm handing around. I'm not sure. You see the variation in rings there, and that's under the microscope getting measured. And then we end up with this. This is a representation of the samples. So we see 1500 to 1900. We see all of our samples. We see the sample size, and we see the depth in time. So there's not a lot. There's a few samples that reach well back in the 1500s back here. So it's a very long chronology. We only have 14 of those cross sections actually worked out. So there's 14 in total. Usually an A path and a B path, maybe a C sometimes in here. So 2 or 3 paths. What I'd like to do is go back and sample some more and grow the sample size here and hopefully grow that depth back further too, but a really nice chronology from rotting logs that have been in their tidal zone forever. I won't spend a lot of time here, but basically the inter-series correlation was 0.549, which is decent, not, I would expect a little higher with Hemlock, so it's a little bit low, but the sample size is kind of small. And this is just the correlation matrix of the 50-year periods overlapped, and basically what you see here are pretty high numbers and not really many flags, a couple flags here, a couple flags here, but generally even far back in time everything's correlating quite well, so a really nice clean chronology. And this is the average master chronology once everything was done. It's been standardized, which basically means it's kind of set scored around 1. And you can see back farther in time where the sample depth trails off, you get a little bit more variation in growth, but generally you can see that there were good times, there were bad times. There was lots of periods in here where there was probably some kind of climatic or environmental disturbance.
What's written on the vertical axis?
Well, that's just an index, our standard index. It's basically a
How is that defined?
How's that defined? Well, it's basically Z scored. It's basically Z scored.
It's growth.
So it's just centered around 1. So just showing the variation. I'm not. It's been standardized. So I'm not showing you the raw curve here because it's been standardized.
The width of the. It's referring to the width of the.
Yeah, the radial. It's the radial growth. So yeah, it's not in millimeters, but it's the width of the tree rings. So yeah, we're looking at. There was some valleys in here where the trees were not growing very well at all, and then other times where they were growing very rapidly. So where is this wood from? There's this wharf here, but where was the wood brought from? I want to know where the forest is. When I'm looking at a house that's been axe hewn, it came from the backyard or down the street or something. This wharf could have come from anywhere. So I used some other hemlock chronologies that we had, one up in Charlotte, Liddell Park, Fredericton, Bowater, Mersey. No, that was Bowater. This is from Tobeatic somewhere, a couple up in Cape Breton. To try to discover how well the growth matches with these other chronologies. So in this case, we're only looking at a 40-year period here, so a very short period, but some of the chronologies don't reach very far back in time, especially these two here that are really close by. And I was really concerned with those because it's probably from this area, but it could have been floated or brought by rail from anywhere else. And in here we can see that Bowater, Mersey, and Little River in Cape Breton match very well. Tobeatic, Bowater, they're really close together. They have very high correlation. What else? Little River, Kelly's Mountain, those are both in Cape Breton, very high correlation. But when we look at, let's see, Pink Rock versus a lot of these other ones, it matches the best with Charlotte, which is northern New Brunswick, very northern range limit of Hemlock. That doesn't make a whole lot of sense. Did they ship it all the way around from Charlotte? That sounds kind of crazy. The thing we got to be careful with here is it's only a 40-year period, so it's not very long, and this is a pretty low correlation given the shortness. And it doesn't match very well with the other two that are near the Moncton area. So when we get rid of those two and replace them with a wharf in Mersey-Bucto and a wharf in Grand Pre, and look over a much larger time span of almost 300 years, almost 300 years, we end up seeing that, those Little River, where is it, Kelly's Mountain, Little River, very high correlation, Grand Pre and Bowater Mersey, very high correlation. So the ones that are closest to each other having very high correlations makes a lot of sense. And what we see here is that Pink Rock has an extremely high correlation with Mersey-Bucto Wharf. So it's also a wharf though. It's not a stand of trees. It may have been moved as well, but it's on the other side. It's on the Northumberland Strait side where the Pink Rock is in the Bay of Fundy. So some location in between the two makes a lot of sense. So when you look at those two chronologies overlapped, to me, doing this work for quite a while, over 12 years, this looks like two sides of the same tree, two paths measuring the same, like they match so well. So there's a very strong fit here. So it looks like these trees are from the eastern lowlands, and they were probably brought downriver or maybe by the rail line, because it goes really close. Right now, I'm working on the largest Dendroarchaeological project done in the Maritimes. So we're dating about 20 structures, early 1800s, late 1700s, in the Tantramar region. So we're building on the archaeological side of things. Those species that we see often in there, red spruce, white pine, sometimes larch cedar in basements, those are the types of things we're getting out of these buildings. There's some pretty good coverage from spruce and hemlock between living and archaeological samples. Pine, the King's Mark didn't allow people to actually use white pine in construction, so there's not much of that there. But essentially, we're working towards this full spatial coverage, kind of tree ring library for the Maritimes. And once we kind of have something that's more complete, then we will be able to analyze that for past disturbances. We get hindcast, climatic disturbance. We can look at the productivity of the forest before disturbance really got involved there. So there's some really interesting questions that are in some of that analysis. But we're still building that library of tree rings out, and we're getting close to be able to do some of that analysis. So I want to start doing some preliminary work with spruce and hemlock because we have such good coverage, but I also need to catalog some of those old growth sites for living trees that were in those missing spaces and heritage structures. I'm not a historian. I need the help of historians to locate some of these things. And once we have that, I can keep building that library. So that's where the lab is headed. Those are the types of things that we're